Let's look at 1.4. 1.4 wants us to calculate the numerical value of, number one, area of triangle ADC. When I talk about the area of triangle ADC, look at this theorem. The theorem, area la over area la is equal to this side over that side. But this must have the same altitude. Let's go to the problem that we're doing. The area ADC over area of ABD. Let's look at those two triangles. ADC, ADC. It's this triangle here. It's this triangle here. ADC. This triangle. This triangle here. And which triangle? Area of ABD. ABD. This one. This one, this one, this triangle, this triangle. AB. It's the way area la over area la. It becomes that theorem. Triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. So area la over area la will be equal to this for this base. That's what we're writing. So area of triangle ADC over area of triangle ABD will be equal to this base over that base. Triangles with equal altitude have the ratio of their areas equal to the ratio of their bases. So in other words, area of triangle ADC will be equal to this base over this base. What is this base? In other words, what is DC? DC, are we not given DC? Yes, we are. It is 9 centimeters. So this is equal to 9 over what? Over that, which is BD. What is BD? We're also given it 6 centimeters. Over 6 centimeters, over 6, which will be equals to, number again, 3. 3 into 3 goes 3 times. 3 into 9, 3 times. 3 into 2 times. So this is the numerical value of that one. All right, I want us to look at this last one, which is very important. It is important that when you do these problems, you also think out of the box. You also think out of the box. Let's look at the last problem there. The area of triangle TEC over area of triangle ABC. Let's look at those two areas on the diagram. Area of TEC. TEC, where is TEC? This small one. TEC. TEC. And the area of triangle ABC. ABC. These two areas. All right. We are comparing this area and that area. We want to find the numerical value of it. Something over something. The area of EC, TEC, the area of this over area of that. It's either I use ama ratios or I use ama dimensions. I know this distance is together. Njoba kade I ratio 1 nalapho 1, okusho la 3, nalapho kusho 1 or 3 centimeters. If the ratio like 1 is to 2, so what is the ratio? Dimensions here to be 6 centimeters, because it's 1 is to 2. All right. Okay, let me check what we have here. Area of this over area of which one? Of the bigger one. And this is Sizaula. And this is Sizaula. When you read this one, it's TE what? TEC. Oh. The other one is what? It's ABC. Konke kusisa ku C. Konke kusisa ku C. Konke kusisa ku C. Actually, there's something special about that C. In this triangle, included angle. It's the same thing, Nangala. I do have this dimension, I do have this dimension in the bigger one. C becomes the included angle. Now it takes us back to trigonometry. Which part of the trigonometry? The topic called Triangle Formulae, where we use the 3 rules. The rule, the cosine rule, as well as the area rule. Remember here, we're dealing with the area. Therefore, we can't use the sine rule or the cosine rule. It's definitely the area rule, because we're looking for the area. And there's no perpendicular height here. There is no altitude. We cannot find the altitude here. So we can use, to find the area of TEC, we can use the topical triangle formula, which is the area rule. Now, it's in the area rule. For me to be able to use the area rule, I must be given the 2 adjacent sides and the included angle. Now, if I'm using this triangle, Do I know this dimension? Yes, it is 3 centimeters. Do I know this one? It is the same, 3 centimeters. It's either you use AMA dimensions or you use AMA ratios. Both will give you the same result. So if we go with centimeters, it will give the same result. AMA ratios, but you don't have to mix the two. Now, if 7 centimeters, 7 water, ratio, 7 water. Right, let's go with centimeters. We're looking for the area of triangle TEC. Area of triangle TEC over area of triangle what? ABC. ABC. What is this going to give us? All right, let's try with the area of triangle TEC. It's in the area of triangle. It have the parallel side times sine of the included angle. Isho jalo area rule. It have the product of the parallels of the given side of the adjacent side in this particular case multiplied by the sine of C. So the area of TEC, it will say half, what side is that? It's TC, half of TC times this other side. What is this other side? It is EC, sine of the included angle. What is the included angle in this case? It is C. That's what the area rule is saying to us. It's half of this side times this side, sine of this angle. It will give us the area of this smaller one. The very same way, that's how we'll find the area of the bigger one. Let's look at the bigger one. Why did I use this side? It's because I do have their dimensions. The bigger one is the area of ABC. ABC. C again becomes my focal. Can I make C the included angle in the bigger triangle? In other words, do I have these dimensions where I'll put C part wow? Yes, we do know. Kuba. Let me check. This is 6 plus 9. What is 6 plus 9? It is 15. So we know that this dimension is 15. What is this one? This is from here to here, it's 3. From there to there, it's 6. So it's 9. And we do have the included angle in this case, which is C. It is important that we should use our angles, the common angles, so that as a harm by our angles. Let's do this thing. So the other one will be half over half of what? Of AB, these two sides. So it's AC times this other side, which is BC, sine of the included angle, which is C in that particular case, sine of angle C. Right. We're looking for the numerical value of this. This then will be equals to, okay, let's push in dimensions. Even before we even push dimensions, you can see that sine C will go with sine C. That's why we took our angles afanayo, so that they will cancel out. We took C and we also took C. That is the main idea. Whenever you get to this, it's usually at the last part of these types of problems, you'll see that at times it might not be this angle and this angle, but it's angle we'll do the second example and show you exactly that. Let's move on. We can see that this C can go with that C. Anything else that you see there that can cancel out? Yes, we see it. It is half and half. So this half can go with that half. Let's push the actual dimensions there. I can show you that whether we use dimensions or whether we use ratio, we'll come to the same solution. Let's start with dimensions. What is TC? How many centimeters is TC? TC, where is TC? This is TC. It is 3 centimeters. TC is 3 centimeters. So this is 3 times. What is EC? EC? EC, it is also 3 centimeters. So it's 3 times 3. So these are gone, divided by those. What is AC? Let's look at AC. AC, how many centimeters? It's 3 centimeters plus 6 centimeters. It's 9 centimeters. So AC is 9 centimeters times what? Times BC, 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 this whole one. So it's 9 plus 6, it is 15 centimeters. So this is 15 centimeters. So we're looking for the ratio. Okay. What is 3 times 3? It's 9. Can go with this 9. It's only 1 on top. So the actual answer is 1 over 15. This is the numerical value of triangle TEC over area of triangle ABC. Ama areas also khuluma ngawo. Remember last applying la area rule kani ye trigonometry. which is also part of our paper 2. Suppose one learner will not use actual dimensions, centimeters. They will use ratios. What will we get? Let's just take it from here. What is TC in terms of ratio? TC, let's look at it. TC. Yes, what is the ratio? It is 1. Ratio, if I say it is 1. TC, it's 1. We want to check if we're going to get the same answer. EC, let's check EC. What is our EC in terms of ratio? EC, the ratio is also 1, all right? Over. What is AB? AC, in fact, AC in terms of ratio. AC, AC. The ratio is 1, 2. So that one, it will be 3. Yes, it will be 3 times. Let's find BC. BC in terms of ratio, BC. Khumbula ukuthi u6 lo, u6 centimeters, i-ratio yakho soku2. So, kubhaliwe vele i-ratio la u2 6 centimeters. Njengoba nala ku6 centimeters, kusho ukuthi i-ratio izoba 1 nakhona, it will be 2. So this whole dimension, it will be 2 plus 1, which is 5. It will be 5. So the actual answer here will be, what is 1 times 1? It is 1. What is 3 times 5? It is 15. So it doesn't matter whether we use the actual centimeters or you use the ratio, but don't mix them. Once you mix them, you'll be losing it. So it will give us the very same thing. Right. The next time, I want us to look at the next example number 2. Thank you.